Okay, so in this video, we're going to look at how to work out the forces in chains or ropes or wires where we've got a mass suspended or slung by them from a ceiling, say. So just for example, let's say that our mass has a weight of 1000 newtons, and that is straight down, which is due to its mass and gravity. And then let's call the tension in the left-hand chain, let's call that force 1. And the tension in the right-hand chain, we can call that force 2. So F1 and F2 are pulling out to the side and they're pulling upwards, and they are counteracting the vertically downwards force from gravity. Now, for equilibrium, we can assume that this whole system doesn't move. So what we can say is the force left is equal to the force right, so that there's no horizontal movement. And we can also say the overall force up is equal to the overall force down, so that there's no vertical movement. So we need a bit more information. So let's draw a horizontal line to look at what the angles are that these two forces are pulling at. So let's say, for sake of argument, let's say that we could call it theta 1 or angle 1. We could call that angle 2 or theta 2. Let's say that theta 1 is 45 degrees, just for an example. And then on the other side, we could say that theta 2, it looks, it's not drawn to scale, but let's say it's 40 degrees. So force 1 is pulling up and to the left. So it's got a vertical component, the vertical component of force 1, and the horizontal component of force 1. So the horizontal component of force 1 is to the left, and that is the hypotenuse F1 times the cosine of theta 1. And we've also got, on the right-hand side, we've got F2. Part of its force is pulling upwards, and part of it is pulling to the right. So the horizontal or rightwards force component of F2, if you treat F2 as a hypotenuse, F2 times the cosine of angle 2 or theta 2. Now, because there's no resultant left or right movement of this system, we can say in the horizontal plane that F1 times the cosine of angle 1 must be equal to F2 times the cosine of angle 2. So that sorts out the horizontal forces. We've got an equation for those. Now let's look at the vertical component. So the vertical component of F1, we could label it there, and the vertical component of force 2, we can label it there. What we can say from here, the overall upwards forces must equal the overall downward force, otherwise the mass would move up or down, and that's the same for the horizontal ones. So we can say that force 1 times the sine of angle 1, that's the upwards force from force 1, added to the upwards force from force 2, which is F2 sine of its angle, those two added together must be equal to the weight downwards. So that must be equal to 1000 newtons, or mg, whatever your mass is and whatever the gravitational field strength is. Mg is the weight on Earth. So the total up equals the total down. So we've got two equations and we've got a few unknowns. We know what the angles are, but we don't know what the forces F1 and F2 are. So let's start. If I call this equation 1 here, and I'll call that equation 2, let's rearrange equation 1. So equation 1 gives us, if you divide both sides by the cosine of theta 1, we end up with F1 equals f2 times the cosine of theta 2 all over the cosine of theta 1. So I've just rearranged equation 1 there. I haven't changed anything really. But now we've got something that's just made up of f2 on the right hand side, and we can substitute, because that is equal to f1, we can substitute this into equation 2. So equation 2 can now be written as, instead of writing f1, we can write what f1 is equal to, which is f2 cos theta 2 over the cosine of theta 1. So that's the f1 part done, multiplied by the sine of theta 1, which is that bit there, plus whatever's here, f2 sine theta 2, f2 sine theta 2, that is equal to our weight of our mass. In this case, it's 1,000 newtons. So I've just zoomed out a bit, and now we've got this sort of equation here. And what you might notice is there's a common factor. There's f2 there, then a plus sign, and f2 there. So we can factor those out, those f2s. So we end up with f2 multiplied by cosine of theta 2 multiplied by the sine of theta 1, and they are both over the cosine of theta 1. So that's this part dealt with f2 as the factor. Then the other part of the bracket, we've got f2 sine theta 2, but f2 has been taken out. So we've got plus sine theta 2. So all of this bracket is multiplied by f2, and it's equal to 1,000 newtons. But at this point, there's a way we can simplify, because here we've got sine theta 1 over cosine of theta 1. If I do up on the top right here, sine over cosine is the same as sine multiplied by 1 over cosine. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So 1 over cos would be hypotenuse over adjacent. So sine over cosine is opposite over hypotenuse times a hypotenuse over adjacent. The two hypotenuses cancel, and that gives us sine over cos is actually opposite over adjacent, is tan. So what we've got is f2 multiplied by the cosine of angle 2 multiplied by sine theta 1 over cos theta 1, which is tan of theta 1. And then we add inside this f2 bracket that we're multiplying both terms by f2, add sine of theta 2, and that is equal to our load. So if you want to get f2 on its own, if we've got f2 times something equals 1,000 newtons, then we divide both sides by the something. So f2 itself is the load divided by the cosine of angle 2 multiplied by the tan of angle 1 added to the sine of angle 2. All of these, the angles are known, they're given to us in the question. So all of the trig answers we know, and we know 1,000, so we can work out f2. So to get some actual answers, force 2, which is this one up here, the tension in that wire or chain on the right hand side. F2 is 1000 newtons over the cosine of angle 2, which is 40 degrees, multiplied by the tan of angle 1, which is 45 degrees, added to the sine of angle 2, or the sine of 40 degrees. That comes out as approximately 709.808 newtons. So that's F2. So now we've got F2 as roughly 709 newtons. From equation 1 here, we can find F1. So F1 is equal to F2 times the cosine of theta 2 over the cosine of theta 1. And we know all of those numbers. So F2 is 709.808 to 3 decimal places, multiplied by the cosine of angle 2, which is 40 degrees, over the cosine of angle 1, and angle 1 is 45 degrees. And that is F1. So F1 is slightly larger, and it is 768.971 newtons to 3 decimal places. So there's F2, all worked out nicely. There's F1, and we've got an answer for that. So hopefully that has come in useful. It came in useful for me when I couldn't find any decent resources on this a long time ago. So there you go. Just be careful that you don't mix up your angles, label your diagram, and thanks so much for watching.